Welcome to an example of plugging one function into the other where we've got fractions. So let's take a look at what's happened here. We got this function, which is a fraction, and this function, which is also a fraction. And they want us to find f of g of x and g of f of x. So this can be pretty messy. Let's go through it. So on the first one, they want f of g of x. Let's bring this down to here. And so what does that mean? That means g of x is inside of f. That means I'm going to take all of g and I'm going to plug it in right there and right there, right there and there where we have the f. That's what an x is in a function. It's like a hole where you plug this stuff in. It's like the holes in a toaster is my usual analogy. So what do we got? So it's going to be 5 over x over 5 over x minus 7. See what happened there? I just took this 5 over x, I put it in the top, the hole in the top, and the hole in the bottom next to the minus 7. That's what it means. That's what the x is. It's a hole we plug into. Okay, now, this is what we call a complex fraction because it's fractions over fractions. It's ugly, very ugly. We don't want to leave it this way. We want to clean it up. How do we do so? Let me give you how you handle a complex fraction. Number one, circle all, let me say that a little better. Circle all the items under a small bar. So circle all, that'd be this x and this x, right? Those are the items under the small bars. I'm trying to make this a little cleaner here. So circle all the items under the small bars. Number two, the LCD equals one of each type of those items. So it's a common denominator, LCD, least common denominator. And how you find the least common denominator? So I have x and x, right? That's what's circled here and circled there. X and x, and right, that x and that x, doesn't matter what order. So, but notice these are important words here that you catch these. One of each type. So I have x and x. So the LCD is just going to be x, one of them. You don't use both to make it x squared. Now, if the other one was something different, like it was y, or it was a number like 3 or whatever, then the LCD would be x and 3. I'd probably put the 3 in the front, doesn't really matter. 3x. Is that making sense? So you circle all the items under the little bars, and then you use one of each type. Put it all together, that's the LCD. And this, it'd be 3x if we had a 3 and an x. But if we just have an x and an x, it's just x. We don't use them both. We don't make x squared because we only use one of them. We only use one of each type. We don't repeat types. Like you're going to the store and you say, I'm going to buy one of every type of thing at the store today. One blender, one toothpaste, on you go. That's what we're doing. We're taking one of each type of thing under the denominator. So since we have the same type twice, let me get the color right here, x and x, I'm just going to only take one of them, just x. Okay, great. Now what? Now multiply all terms top and bottom by that LCD you just found over 1. So multiply the top. So let's just take it. So what is it? It's x. LCD is just x. So x over 1 to that term. X over 1 to that term. And here, let me clean this up a little bit. There we go. And x over 1 to that term also. See how I did all the terms on the top and the bottom? That's what's required to be legal, right? When we mess with a fraction, we have to do the same thing to all the terms on the top and all the terms on the bottom so we don't change the fraction. We just change the way it looks. I always call it plastic surgery. Removing the wrinkles, it looks different, but it's the same person. It's the same fraction it was before, when you do the same thing to the top and bottom, you're not really changing it, you're just changing the way it looks. Okay, that's what we did. We multiply top and bottom by LCD over 1. And the LCD is one of each of the items, one of each type of item under the bar. Okay, now, why are we doing all that? Well, because we can cancel. See how these will cancel now? And these will cancel. So what are we left with? Only 5 on the top. 5 over 1, that's just 5. On the bottom, just 5 here, minus, and 7x. And that's our answer. Why is that better? Because that's a normal fraction now. It's not a complex fraction anymore. It's not fractions over fractions. It's a normal fraction. It's simplified. It's cleaned up a little bit. And there's how we do it. Let's do the other direction, and that'll be helpful. Let's do g of f of x. So let's bring it down here and let's rewrite our functions. What was f of x? X over x minus 7. Okay. So here we go. F of x is x over x minus 7. G of x was at 5 over x? Yeah, 5 over x. And this time we're going to go the other way. We're going to go g of f of x. So we're going to take f and put it in g. So all of f goes in the hole, the insert slot in g, which is right there, right? That's what the x's are in a function. They're the holes you plug into. So what do we get then? 5 over, and then we plug in x over x minus 7. All right, good so far? I hope. Now let's go through our steps. What do we do? Well, let's go back to the 3 steps. Step number 1, circle all the items under a small bar. Well, this is the only item under a small bar, right? That's it. That's all there is. Up here there's nothing, there's no denominator. All right. So, and then that is the LCD then. So the LCD is just that. It's just x minus 7. And now what do? That's step 1, step 2, whatever it is. Multiply top and bottom, all terms, by LCD over 1. So I'm going to multiply top and bottom by, let's do it, x minus 7 over 1. X minus 7 over 1, right? LCD over 1, and the LCD is x minus 7 because that's the only item under a little bar. So what happens? These cancel. On the top, we have 5x minus 7, right? These guys are just multiplied because they're both in the top. On the bottom, these guys canceled, and we just have x over 1, or just x. You can leave it like that, or you can distribute this. It's actually good either way. 5x minus 35 over x. Both those are totally fine. This is a fine answer. That's a fine answer. Either one's good. You don't have to distribute. They're both normal fractions, aren't they? Both of these. We just changed it from being a complex fraction. This was a complex fraction, fractions over fractions. We multiplied top and bottom by LCD over 1, the LCD being what's under the little bars. So there we go. That's how we handle fractions.